So I want to try and see whether I can help you and help myself to know how to be able to make sense from multi-local sequence typing. I mean, we use it for species identification, but when we get the output, usually you will see that there are what we have another data that comes with it. So um, let's look at how to make sense from it. Watch on, and then you will see. Trying to get a proper outlay that may be better off. I think this looks a bit better for me. Okay, yeah. So I'm already sharing my screen. This is what I'm talking about. So I just ran MLST, and then this is the output, as you can see around here. So these are the housekeeping genes. This is the sequence type, as you can see in column B, where I've highlighted. Then, then the housekeeping genes are there, and each of the housekeeping gene, you can see into bracket there is a number. That number is the allele identification number. Now, as you can see on this particular housekeeping gene, is 10, 11, 4, then in that order. When you have it this way, it carries another information. If you have this sample from here, and that sample has the same allele identification numbers in all the 7 housekeeping genes, and then you have another one that have the same, then it means they have some genetic relatedness. And if you understand bioinformatics, you know what I'm talking about. So how do we make sense from it? First of all, so we have it this way. Once we have like basic mathematics, when you have a certain character so repeating itself, why don't you leave it on top here? So this housekeeping gene is from C. So what we need to do is we need to extract all the housekeeping genes because it's the same thing repeating, and then leave only the allele identification numbers and see what we can do. So I did that already, and that is the results we have here. So we now have only the housekeeping genes and then the species and then the allele identification numbers which are here. Now the next thing is how do we know which of these samples are having the same allele identification numbers? The easiest way to do it when you have a large sample is to generate a heat map. I see, and the heat map will allow you to be able to see which of them are genetically related, which of them are not genetically related, based on the allele identification numbers of the housekeeping genes. So let's do that quickly. So I'm going to go to R Studio. I've already generated it, and then I'm now going to show you how it works. So as you can see, I've generated the heat map of it, and then this is how the heat map looks like. So let's see how we can. And from this heat map, you can actually see the species which are genetically related and those that are not. But let me close that up, and then we start afresh. So I'm going to clear the whole of this, everything here. Maybe I should brush the and leave everything black. So when we come here, the first thing to do is to make sure that we read our data into our R Studio. But we need 2 packages to be able to do this. One of them is the P heat map, and then the other one should be the the color palette. What is it that we can use to be able to color it, and then I think that will be okay. I think these are the 2 that I'm talking about. These 2 libraries, they are the ones I am talking about. So now let's go. First of all, we need to read the data. So I'm just going to call the data MLST. You see, and then we have to read our data into it. So we just simply read it there. So we say read dot. We want to read it as a table. You see, I'm reading as a table. Okay. So I want to read it as a table. Okay. And so we want the header, the table header, yes, to be true. So we're going to keep the table header. And then because we are not going to import it, so we use the text function or argument to be able to bring it in. And so we can have this over there. So we now copy the actual data, which is a table, and put it here as a text file. Instead of us saving as a text file and importing it, we have to be fast about it. So we now come to our Excel here and come. This is our data that we have inserted. I'm just going to highlight the whole of the data after we have cleaned it up to this point, and then we copy. So I'm going to my R Studio, then I need to paste it here, and then I need to paste it in between, and then that is it. So after we've done that, we simply run it, and you can see that what is it? We have inserted it, and then everything is there. Yep, yeah, everything is here. Now let me check something and see. I'll use the head function and say MLST because, and so as you can see, when we do the head of it, you can see that the table has been properly read. Now the next thing is, now that we have read it as a table, we need to do some few things. We need to assign the rows and we need to assign the columns. Okay. So first of all, let's come here and use a function called names. I don't know if this function will work with it. So the variable that is holding the data right is MLST. So we run it and we can see these are the names of the column headers, which is here. So now that we know that it is okay, so we need to assign row names. So we use a function called row names like this. And then we assign the row names to this variable called MLST. So we come out of it and then assign the MLST, and then we simply want to select the species. So we want the rows to be named after the species. So we run that, and then we are good. The next thing is to give it the columns. But in this case, we don't actually have to say column names again and then also give it columns. So what we're simply going to do is we're just going to copy what we have here, what we have already gotten around here, and just going to copy that out and then come here and do something. So we come here and say sorry. So now let's create a new variable called MLST. This time around, uppercase one, but MLST, and then let's put it underscore one, like this. And then we are still going to use the same MLST. And then we are saying that we don't want, but before we do this, I should have dropped this particular, I think it's okay. It's okay. So we use the MLST that we have here, and then use our index function, separate rows and columns, then use a vector and say that paste whatever that we copied from here. So we want all the columns to have these names because the rows, we have already given them row names. So the one the columns also have column names. Because we're going to generate a heat map, we don't need another heading somewhere. That will be conflicting. So we come here. The reason why it's underlined because there are no commas. So R is seeing the spaces as characters. So we just put commas in between, and then that will be all. See that it will go. Yeah, that is it. So we now run it, and then that is it. So we now have our row names, our column names are okay. The next thing to do is to make sure that we convert this into a matrix because we are going to generate a heat map, and arrow that cannot generate heat map from a table, a data that is structured in the form of a table. So we'll create a new variable called MLST underscore matrix M, and then we convert it to say as dot matrix like this, and then we put the MLST underscore one here, like this, and then we are done. So we've converted it from a table into a matrix, and we pack the data or the results into this variable. So now that we converted it into matrix, that is all. The next thing is to now generate our heat map. So now this is the ordinary heat map everybody knows. So I can simply say a heat map here, and now put the MLST underscore M, and then run it. So you see our heat map is here. But this kind of heat map is the archaic type. Because possibly I don't like this type any longer. You see, now we have the heat map that is showing our columns as we can see. The housekeeping jeans are here. in that order. And then we can also see the species. After that, I'll show you how to interpret this heat map. But now let's continue. So I'm brushing this off, or let me leave it and then generate a different heat map that will look much more better. So we come here and use the P heat map, which we have already from the P package, the P heat map package. So we say MLST underscore M like this. So let's generate it without adding anything. So look at how it looks like. So you see that heat map comes with a legend. And then that's how it looks like. So we can see we now have our, what is it? Our data, our housekeeping genes. As you can see, there's 7 housekeeping genes, and their allele identification numbers are all aligned here, and the species on the y-axis, and then our legend is over there. But let's also add some few things to make this look a little bit more. So we add a color, and then the color we can use the color. I think R has some color, yeah, this, and then it has this brew something, brewer, I can't remember. Yeah, is this, and then we need to put some figures inside. I think if I have 5, and then I have Y, I think it's RD, and then maybe 256. I don't know if this is okay. And then let's leave it over there and run it again. See, I think the argument is not well positioned, but this is the what I'm talking about. I've not been able to remember it quickly. This function, this argument here. So I want to choose a random color by itself. Yeah. So I'm going to just copy it from here all the way up to this point. And then I'm going to bring it down here to where our color. So I'm just going to cancel the whole of this, delete the whole of this, and then paste it over there. And I think that will be fine. I don't need this. Or yeah. So maybe I may rather need it at the end here. I'm sure I need some comma here. So I'm just trying to get the code in order. I think, yeah, so let me get back there and see if I can. I keep getting that code wrong all the time. It's not today. So yeah, so I will simply come here, delete this, delete that, paste it over there, and let's see if the code works. Now, oh yes, I have repeated color. That is where the error was coming from. So yeah, this one is now better. So if we zoom it, we can see that our heat map is getting a little bit better. But let's add more things to make it much more better. So here, when we move, we have our we add some few things. So we can say maybe, let's say font size. So we can have the font size on the row side, and we give that, let's say 10. Then we have font size, column size, and that will be 10. So let's leave it at this point and run it again and see. So the font size, you see some changes have occurred. So let's say we have scale, and the scale should be based on the rules. I don't know if I'm what is it, if I'm right on the rule. So let's see. I think maybe we don't even need it. Now, if you want the color plate to change, the first one I used was 256. Those of you who understand colors well, you know what this. You can change these figures here and there, and then you're going to get it right. So you see the color will keep on changing bit by bit, and then you are good to go. Now, the other things you can look at is we can remove the clusters, we can put the cluster, we can add font color, and then in that order. So here, if you don't want these clusters to be there, so we could have come here and say we cluster on the row side, so we say true. Then we can also cluster on the column side, cluster underscore column. Maybe the cluster is not worse, but because I've not added comma over there, so so we cluster on the column side and we say true, and then we can maybe add maybe maybe scale. The scale is I don't know. The scale should be based on the rules, but I don't know if I've spelled the rules correctly or rule, and then but it's like I'm getting the rule wrongly. So let me see how it was here. Yeah, it's supposed to be because it's not a variable, it cannot stand alone like that. So it's supposed to have been in double quotes. So yeah, and then we run it. Now the heat map is getting to the point that we actually wanted to envisage. So here, if I zoom it out, you will see that it is looking much more better. So maybe we should add a title to it. So the title in most cases we use main, and then the main we can say MLST Paleo profile, and that's it. So we just want to add a title to the plot we have generated, and so now we can see the plot we have generated. MLST array profile is there on top. We can see whatever. So we have the clusters, and then that is it. Now our heat map is ready. So now we've succeeded in visualizing the MLST results and getting it to a very good shape. For instance, we now have, let's say, if I now look at it, this is the housekeeping gene one. Another housekeeping gene here. All of them have now been put in blocks. Now, if you pick on one block and the colors are the same block, same colors, like the first two where my cursor is pointing. So this first two, not the top one, the first two, so the colors are the same in one block, same another one, same another one, same another one, same another one, and then in that order, then we can say that those species have some genetic relatedness. Now go all the way to here, down there. You can see this one, two, three species. The same color in housekeeping gene ICD, the same colors here, the same colors here, same colors here, same colors, and then same colors. So it means those three species, bacteria species, are genetically related. And then in that order, you can check that throughout. But if you wanted to get a pattern, this is where you would have worked on. You should have arranged the data here in that order. And then you'll be able to get a pattern as perfectly as possible. And I think you know how to be able to do that. But basically, this is how we make sense from MLST, and then we can interpret it. If you want, you can collapse one of these. You just go to the arrow code here, and then maybe that's the columns, right? So the columns, we simply put the F, and then rerun it so that we collapse the column classroom, and then we saved it. Yeah, and so we collapse that part, and then I leave the the species side to have some clustering. And then we are done. So now let me zoom it and then you see. Yep. And then the heat map is now looking better. And that's it. Data analysis is about intuition. You look at the way the data looks like and you come out with your own way of how to make sense from it. And that's all. I hope you understand how you're able to make sense. So another time I will show you another way that you can generate. But this particular heat map is not a heat map that is showing correlation or collinearity, or it's just showing you, it's just a comparison of what what are the items that are the same and what are the items that are not the same at different blocks or at different chunks, meaning in order. So that is why I had to go through the table parts and then in that order. Yeah, thank you. I will see you in a different video. Bye bye. Okay, so I hope this has been very useful. Thank you.